Hello everyone, this is Rishali and welcome back to CSN IT Tutorials by Rishali. In today's session, we will discuss binary search tree implementation in Python. Here, we will implement insertion, search, deletion and traversing methods of binary search tree. Let's start the session. So, Python program is always start from the driver code. We are using bottom to top approach. So here, your driver code have started. Here I have mentioned comment to each and every line. That's why it is easy to understand. Now first step is you have to create the object of the class. In your program there are total two classes. First class, that is node class, that we are using for creating the structure of node. And second class, that is binary search tree class, BST class, where we are performing all the operations on binary search tree. So first you have to create the object of BST class, and object is small bst. Okay, this is your object. In Python we are directly creating the object equal to class name. Next step is now you have to insert multiple values in binary search tree, right? So for that purpose we are using the for loop, and the syntax is for value in. So we are mentioning all the values there. So this value we will put in binary search tree one by one by using for loop. After that we are calling insert method, that is object dot function name bst dot insert, and there are total two parameters, bst dot root and value, because we will start the insertion from the root node, and we will keep values of each and every nodes as per the structure. The logic of binary search tree is value which is less than root node is on left side and value greater than root node is on right side. So this logic have mentioned in this insertion operation. So let's see here. So before insertion, first you have to create the structure of node. See here in this particular part. So class node, and the function is def init. Def declare the function in Python. Now we are using the init function. This is a constructor initialization method, and they have a two parameters, self and key. Self is a new instance that being initialized by the constructor, and it is automatically passed by the Python. So we are assuming that self means the node, and we are entering values in particular node. So these values I have mentioned by the key. So there are total two parameters, self and key. Now as per the structure of node, there are total three parts: key, left part and right part. See here. So this is the structure of node, right? So in between there is a node. We are assuming that self keyword. Okay. So self dot key means this particular value, that is 50. Then self dot left means left side, and self dot right means right side. They assume the pointer, left pointer and right pointer, and initially both are the null. So this is a structure of node and the class of the node. Now see here. So this is a structure, self dot key equal to key, self dot left equal to none initially, and self dot right equal to again none initially. So this is the structure of class node. After that we are declaring the class BST. Okay. So this is a binary search tree class. Now first step is again we are using the same function, that is init function, to initialize the constructor method, and we are passing only one parameter now, that is self. Initially your tree is empty, means self dot root is equal to none. Initially there is no any node is present in your tree. So this is a initialize method. After that we are calling insert method, right? So this is a structure of insert method. See here. Okay. Now we will learn this structure according the if else if structure. Okay. See. First def insert. This is a particular function. We are passing three parameters: self, root and key. Self means we are assuming the particular node. Root means we are starting from the root node, and key means we are inserting the key in particular node. Now see. This is a if, else if and else structure. If structure indicate if your node is less than root node, so put on left side. Else if structure indicate if your node is greater than root node, so put on right side. and else indicate the duplicate entry. If in your code 70 value is already present, so they can't insert 70 more than one time. This is called duplicate entry. So these three parts are there. Always understand the program as per the modules, as per the parts. Okay. Now see, first if part. So we are assuming if we want to insert 30 now, okay, we are already added suppose 50 because this is our root value. There is no left and right child is present. This is our initial value. Now suppose we want to add the value 30. So 30 is less than 50, right? So check here. Our key value is 30. Root dot key is 50, right? So 30 is less than 50? Yes. So self dot insert function pass the parameter root dot left side. Again they create the particular structure, that's it, this is the left part, okay, and after that creating the node, they call this class node and put up the value, that is 30. So we are using recurrence method here. They repeatedly call insert method because they continuously check whether it is less than root node, whether it is less than left side node, they continuously check it, right? This is called recursion. So again this is a if part. Now suppose we want to add value 70. So 70 is greater than 50. So first we are creating this root dot left part and after that we are adding the value 70. See, our key is 70. 70 is greater than root dot key. 70 is greater than 50. Yes. So self dot insert method is called and we are passing the parameter root dot right. Means they make a structure from right side, create the node, that is self part, and after that add the value, that is your key, that is 70. So initially if else if structure is work. Again in else part they show the message if you already 70 is already there and if you want to add 70 again, so they show the message duplicate entry 70 not inserted. So here we are using printf function. So f is indicate the formatted string, means see duplicate entry, this is a characters or string and key means 70. So you are concatenate string plus integer value. That's why we are using printf here, that is formatted string, and they return the root node. Clear? So if means insert on left side, else if means insertion on right side, and else means to insert the duplicate data. And after every insertion they print the message like particular key inserted successfully and they return the particular node at the end. So this is a basic insertion function in binary search tree. Now just execute the code. See here, these values we are passing in for loop, right? So 50, 30, 20, 40, 70, 60, 80, all the nodes are inserted successfully as per the if else structure. And at the end in else part 70 is already there, right? So duplicate entry 70 not inserted. See here. So in this way this tree, this binary search tree structure have created. So 30 is less than 50 on left side, then 20 is less than 50, less than 30, so again move to left side in this way. So this structure have created by using insertion method. Now next part is now next thing is in driver code. After insertion function have executed, the next you are calling traversing methods. Okay, so in binary search tree there are total 3 types of traversing method. We have already discussed all this traversing method with solve examples in our previous session. So there are total 3 traversing method: in order, pre-order and post order. Every traversing method having the particular sequence. So let's understand. See, first you have to print the in order sequence, after that pre-order, and after that post order sequence. So they call the method object.function name, that is bst.inOrder. We are passing only one parameter, that is root value. Again bst.preorder and bst.postorder. We are calling one by one all these 3 functions. Now let's see the code of this part. See, so this is very easy to implement. See, first def in order, function in order. We are passing 2 parameters, self and root. Self means particular node structure, and we are starting from the root node. Means if root is present, then only you are performing the traversing, right? So the sequence of in order traversing is left, root, right. So first self dot in order you are performing on left side, that is root dot left. After that you have to print the key, that is root dot key, and again you are traversing from root dot right. So we are using the recurrence method. We are repeatedly call in order function. So this is called recurrence. Okay. Now see here in this diagram. Suppose we want to find the in order method. Left, root, right. So which one is the leftmost node? This one, right? That is 20. So left, this is your left part. Again this is your root part. 20, 30 and right is 40. So 20, 30, 40. So left part is completed. Again root is 50. Again left, root, right 60, 70 and 80. So in this way you have to recursively call in order function to find out the leftmost node and rightmost node. So this is a simple structure of in order. Now next one is a pre-order. The sequence of pre-order is root, left and right. Okay. See here. So first you have to print the root key. You can't traverse the root node. Okay. You have to print the root value. After that you have to traverse whether it is left side or right side. So first print root dot key value. After that traverse self dot pre-order root dot left side and self dot pre-order root dot right side. So we are recursively call the pre-order function and visit that particular node. Again similarly there is a diff post order function method and the sequence is left, right, root. So self dot post order first root dot left, then root dot right, and at the end you have to print root dot key. So this is a simple in order, pre-order, post order sequence for traversing. So you have to remember this thing. You just want to print the root value and traverse on left side and traverse on right side repeatedly, recursively. Okay. So in this way you have to put the in order traversing, pre-order, post order traversing on this binary search tree. Now let's see the first output, their sequence. See here, just a second. Okay, see, this is your in order, pre-order and post order sequence is there. Just check once. First there is a in order 20, 30, 40, 50, 60, 70, 80. Check here. 20, 30, 40. Left, root, right. Then 50. Again root. Again left, root, right. म्हणजे 60, 70, 80. Okay. So this is your particular in order sequence. Then pre-order and post order. This is your final answer. Now after that again, so insertion have completed and traversing have completed. Now next thing is searching value. Suppose you want to search the value key equal to 60. So you have to print a message your searching is found or not found. So for that purpose we are calling bst.search method and passing the two parameter root and key value. So they are using the same logic as per the insertion. See. So this is a simple searching method. See here. Okay. So again there are total three parts: if and else part. If part indicate if your root value exactly match your searching value, so they return the root value. Again next if part indicate if your searching value present on left side, so they have searching from the left side of node in left subtree, and else they are searching from the right subtree. So there are total three parts: if and else. So see here, suppose I want to search the 50 value. Okay, now check here. If 50 root dot key is exactly equal to 50, right? Our key is 50 and root dot key is exactly equal to 50. So they return the root node, that is 50. Now suppose I want to search the 20 value. Okay, so check here. 20 is less than root dot key. 20 is less than 50. Yes. So they start searching from the left side. See, search root dot left. Again they check on left side recursively with 30. 20 is less than 30. Yes. So again they move to the root dot left side. And at the end you are visiting the 20. Your search is found at the end, that is left subtree. So in this way, this if else method have worked. And suppose you have to find out 80 here. Okay, so 80 is present on the right side. So you have to start searching from the 50. 80 is greater than 50. Yes. Move to right side. 80 is greater than 70. Yes. Again move to right side. See here. Self dot search from root dot right and passing the value key, that as a parameter. So the recursively call searching method from the right side. So this is a simple code of searching method. Now in our output, see here, your search is 60. So they give the message 60 is found. And if you pass the any value, suppose you are passing the value 100. So search 100 is equal to not found. They are displaying like this. Now next part is perform the deletion operation, right? So to perform deletion operation, you must know about 3 cases of deletion. Case 1, case 2 and case 3. Case 1 means if you want to delete the leaf node. Case 1 means if you want to delete the node which have 1 child. And case 2 means if you want to delete the node which have 2 child. So you know this concept. Okay. So see here. So bst.delete method, they call the bst.delete, and we are passing 2 parameters, bst.root, and we want to delete the value 50 in our binary search string. So after deleting, they display the result. So they call the delete method here. Okay. See here, this is your delete method. Now in delete method, first you have to check that apply the searching method same as well, whether the deleted node present on left side or right side. So you have to perform the if else if structure there. If means your value is smaller than left side, so self dot delete on root dot left means first search the value, then delete that value. This is a sequence. Okay. And if your deleted value is greater than root dot value, so they start searching from root dot right side, and after that you have to perform the deletion. Okay. So if part indicate if you want to delete the root is none, means your tree is not present. This is your if part. Next if part indicate your deleted value present on left side. Else if part indicate your deleted value present on right side. And actual deletion code is present in this else part. Okay. Now see. Suppose your first if condition is you want to delete a particular node, they have only 1 child. Okay. See here. Suppose you want to delete the node. Okay, there is all the nodes having the 2 child only. Suppose you have to delete the particular node. See, suppose there is a particular tree, and their value is 20. This is your root node. Okay, and now again 1 child is present there, right? So I am creating again 1 node, and just a second. Okay. So you have to delete the node 20. So 20 node has only 1 child is present, right? So after deleting this 20 node, what happened here? There is only 1 node is present, right? And the node is only 30. Clear? So how to write this code? See here. Now check that. Either a particular node is present on left side or right side. Okay. So if root dot left is none, means left side no any node is present. So you have to delete the node on right side. And opposite condition is if root side there is no any node is present. Same condition is here. See, if right side there is any node is present, no. So you have to delete the node from the left side because they have only 1 child, right? So after deleting this node, only 1 node is present. Clear? So this is a simple if else if structure, whether your node have only 1 child is present. Clear? Now next thing is, suppose if you want to delete the particular node, they have a 2 child, and the concept is, see, as per the algorithm, suppose you want to delete the value 50. As per the algorithm step, you have to find out either max value from left subtree or minimum value from the right subtree. Okay. So 50, their right subtree is this part, like 60, 70, 80. This is the right subtree. So which one is the minimum value? 60. So you have to find out first minimum value in right subtree, and 60 is there, right? So you have to replace the value 60 to 50, means 60 goes to at 50 slide and 50 goes to here at 60 place. Okay, in this way. So, and after that you have to delete the 50. So just see here. So while deleting the two child of node, first you have to calculate the mean value node from the right side. So for that purpose we are using the function name, that is diff mean value node. So you have to find out the minimum value node. So your current node, we are assuming your node as a current. We are considering this one temporary parameter, temporary variable, that is current. Okay. So your current dot right means node is present on right side. So you have to search on right subtree. Okay. You have to find out the minimum value from right subtree. Now check here. After find out minimum value node from root dot right side. So which one is the minimum here? 60. So this 60 value placed in the one variable, that is temporary variable. Okay. Now this temporary variable placed at the value of key, and after that you have to delete the particular value. See here. Suppose I want to delete the 50. So which one is the smallest? 60 here. So I am replacing 60 with 50 here. Okay. So it goes to 50, and here is we are swapping the value. Here it goes to 60. Right. So we want to delete the 50 node. So this node has no child is present. This is a leaf node. So we are directly deleting this node. Okay. Means this is a remaining structure of binary search tree in this way. So we are swapping the value with minimum value and then delete the node. See here. So we are putting, this is called a swapping method. Right. This is your swapping method, and you are calling self.delete method. There is a right parameter, means on right side, and you are swapping the value from key to temporary, right, and return the root node. So this is a again simple deletion code. You have to practice it. Okay, you have to assume this thing, or you have to remember this thing. First if structure, if else if structure, then again else structure. Under else structure there is a again if else if part. So you have to think logically as per the problem solving statements. Clear? So this is a simple of deletion of node. So here we want to delete the 50, right? So just execute the code. See here. So after deletion 50, you have to remaining only this value. Clear? So this is called as binary search tree all operations. So I have mentioned comment to each and every line. Prepare accordingly. Thank you. Keep learning.